Also from my part, I welcome you very much to the ROS-Industrial event here in Stuttgart. My name is Martin Haegele. I'm heading the Intelligent Automation Division at Fraunhofer IPA. Fraunhofer IPA is the hosting institute here in Stuttgart, and I will talk about the impact of robotics in industry, in society, and I will present a couple of figures, maybe quite a number of figures, on the current market, future outlooks, technological trends, and so forth. Before I will come to the figures, I would like to give a very short introduction what we are doing at Fraunhofer IPA, who we are, what we are working on. My presentation, robotic impacts industry and society. What are the numbers and what are the trends? Fraunhofer Institute, probably many of you not only have heard of the Fraunhofer Society, Fraunhofer Institutes, but also had numerous interactions with us. So we are the largest organization of applied research in Europe. Applied research means whatever we do, whatever we maintain as resources, competencies, infrastructure serves a purpose, and that's the purpose to satisfy industrial R&D needs. So we are distributed all over Germany, in total 72 institutes, and each of the institutes stands for a typical portfolio of activities. In our case, it's manufacturing, engineering, and automation, so we are clearly addressing the production area and also the supplier of manufacturing equipments. Large means that we have a turnover of 2.3, maybe this year 2.5 billion euro. And apart from a German presence, we also maintain overseas institutes and overseas infrastructure. You see here Stuttgart, very on the lower right side of the German map, and our central is in Munich. So probably we will see the facilities tomorrow when we have the visit to our institute. And here you see, of course, the buildings, and what you maybe anticipate is that we maintain large infrastructure regarding labs and testing facilities. So this is, of course, the signature of applied research, that we maintain large labs. In total, we have about 450 engineers, and a good deal of our annual turnover actually comes from direct industrial contract research. And so here you see some of the labs we maintain in Stuttgart. I have marked the ones we will be visiting tomorrow with a red frame. So we'll certainly look into the robotics implementation area and also have a look into the application center, Industry 4.0. As you can imagine, robotics, Industry 4.0, machine learning, data science is at the moment very much in the focus of our activities. So that's the last slide of our profile. We also maintain a complete research factory, which is called ARENA 2036, and ARENA stands for Active Research Environment for the Next Generation of Automobiles. And 2036 marks the 150th anniversary of the invention of the car here in Stuttgart. And of course, the ARENA is a focal point of the local industry, and local industry here is very much influenced or governed by automotive industries, suppliers of the automotive industries, also automation equipment, machine tools, etc., suppliers. So this is, of course, also having a tremendous impact on our portfolio as Fraunhofer IPA, and many actors in these industries come together, form some kind of an ecosystem, common platform, which is called ARENA 2036. And one of the activities is, of course, the manufacturing challenges of the car of the future. And we have here Thomas Dietz, one of my colleagues, who is the manager of the experimental production in this research facilities. Maybe you have seen a little bit the video, and it represents the idea of future car manufacturing. So you do not see conveyor belts anymore. You rather see work cells which are connected by automated guided vehicles, that you also see here the work cells, which are composed of robots or manual workplaces, no fences. So quite a number of the typical trends which we are currently seeing happening everywhere is focused here in this research factory. So now jumping into the numbers, one of my part-time activities or hobbies is also to serve at the International Federation of Robotics. And the IFR is the platform of international robot manufacturers. One of the main purposes of the IFR is, of course, to provide any kind of statistic material, also trends, where robotics is going. And so these are actually taken out of the numbers which we published last October in Tokyo. And from the media, from your experience, you have certainly taken that robotics has reached an all-time high in terms of installation numbers, in terms of shipments, and so forth. And when we look into robotics, where is it used today? Then we see still half of robot applications are found in the handling area. Handling means commissioning, palletizing, depalletizing, packaging, transporting, etc. And here you see some of the ideas how handling actually is understood. Welding, close to 22%, and probably all of you would have expected assembly is much more an application case of robotics. In fact, it's not. However, it's strongly growing, but still assembly is relatively small due to the fact that the assembly process is relatively difficult for a robot to handle or to perform, because in many cases it requires the use of sensors. What we also have is machining, very, very small, dispensing, which is mostly painting. So that's the current pictures in terms of recent installation numbers. Who wants to have more information on all this? Please go to the web link, which is indicated below. There you find already a good deal of free material for download, which satisfies probably most of the needs. The ones who want to have the complete study and want to research how many robots were installed in spot welding in Thailand, etc., have to go for the full paid report. So when we talk about installation numbers or recent shipments, then we see that in extreme strong growth worldwide, and you also see that there's a reason to this. So in 2017, close to 400,000 robots were installed worldwide, and there's a very strong gradient upwards. And you see the reason that, especially due to the high demands in China, shipments are very much increasing. So here you see the indications and percentage. So in 2020 we expect close to 3 million new robots, and still about half of all robot installations go into the automotive field. However, this used to be 54%. Some years ago, you see that there's actually a decline in the installation numbers of robots in the automotive area. What more and more comes into play is the 3C domain, which is communication, computers, and consumer. This is related to all the applications, handling, assembly, gluing, dispensing material for precision goods, from mobile phones to tablets and so forth. Yeah, of course, it's now not very fair to compare, for instance, shipment numbers in China, for instance, to Belgium, to take your example, because obviously the economies are quite different in size. So there's a different measure we use, and that's the so-called robot density. And the robot density actually expresses how many robots are installed in what area, divided by 10,000 workers in that area. So it's a typical normation of that figure. And there we see that, of course, since there's a huge growth in China, but still China is represented under average. Furthermore, you see in this picture, regardless where you produce automobiles today, worldwide, it's very highly automated, and it's probably all of on the same automation level, maybe with the exception of Korea, which indicates a little bit high numbers. And this actually robot density in the automotive field is about factor of 5, 6 higher than in all other industries. What are the technological trends? And there's one interesting trend, and this trend is cost effectiveness. With the increasing numbers, we experience also economies of scale. So this means that robot unit prices are decreasing. And if you take the average price of all robots, regardless of their size, large or small, you end up at a average unit price of about 40,000 US dollars. And at the same time, so you see that that price level has been decreasing over the years. And at the same time, you see also an increase in salary or in wages. And from that chart, you could actually deduce things that never before has automation be as cost effective as today. However, we all know that the robot unit price is almost only a part of the entire cost of installations. And in general, so as a rule of thumb, it's about a factor of 1/4 or 1/5. So usually the system is about 4 times, 5 times more expensive than the robot itself. We have seen more trends, for instance, human-robot collaboration. We don't have official numbers on that area yet, and it's mainly due to the big confusion we are experiencing in this field. So if we really talk about human-robot collaboration, which means that robot and human are working at the same time on the same workpiece in a possible direct contact, there are only a couple of thousands, maybe even only a little bit more than 1,000 installations worldwide. And most of these installations are pilots or prototypes, etc. However, if we look at robots, which usually are also named or called collaborative robot installations without fences, where you have some kind of coexistence, then the number is quite higher. Then the number is significantly higher than the 1,000 or a couple of thousand I just indicated. However, there will be numbers on exactly that topic with a clear differentiation from the IFR starting next year. What also we have is networked robots, and so Milko was referring to the SPS trade fair last week, 2 weeks ago. The main topic here was not only Industry 4.0, but the digital twin or digital shadow, regardless how you want to call it. It's important, the more digital information we have from processes, from products, etc., the more easy it is to actually generate robot programs, the more flexible a robot can be used. Sensors, about 15 to 20%, depending on the application area, of all robots are equipped with sensors. 15 to 20% is not very much. Yeah. However, all robot manufacturers actually try to increase the sensor level of their robots up to the fact or up to the idea that all robots will be equipped with sensors. For instance, when we talk about force torque sensors, this means joint level control or torque control or force torque control, that we see more and more robots which have sensors of these kinds integrated in the equipment. The same holds, of course, also for vision-based sensors, so that we expect that in the very near future, 100% of all robots might come with sensors. And once we have sensors on board, we also use them to detect objects, to identify objects, to model work environments, also to actually recognize the worker. So obviously there's a tremendous potential in endowing robots with intelligence, with cognitive skills. Another aspect which goes hand in hand with human-robot collaboration is the intuitive use. So nobody wants to have an expert programmer working with a robot. So the requirement is also to enable the worker to work with a robot as intuitively as the worker would work with any other tool or machinery. So obviously, intuitive human-robot instruction is on the roadmap of the robot manufacturers. And in fact, there are quite a couple of companies producing or offering already interfaces which endow graphical programming or programming by voice or other capabilities. One aspect which is increasingly coming on the map of current research is machine learning using AI in robotics, and we already can localize three main areas where you use AI and machine learning in robotics. That's of course related to the actual processes, to detect objects, to actually optimize processes, to actually improve on strategies. The second is, of course, program generation. How is a program actually generated out of digital data? And the third case is to improve robot performance. So that's quite interesting, especially when it comes to even less expensive robot, maybe equipped with much lesser grade mechanics or mechatronics, so that we actually can improve on dynamics, on accuracy, and on durability of the robot by machine learning. So these are the trends most of the research labs worldwide have on their research agendas. Another big trend is that we see a lot of robot functionalities outside the manufacturing scenario, and robots which are used outside the manufacturing area are called service robots. And service robots come in two categories. The first category, robots for professional use. This is equipment which is part of a service, which is part of a professional task execution. And the other branch is which is service robots for personal or domestic use. So I have here some examples of service robots for professional use, for instance, agriculture, in the medical field, in cleaning, in transportation, and inspection maintenance, rehabilitation, transportation, defense, underwater, retail, entertainment. So there are a tremendous number of different application areas of service robots. And if you look at the numbers, especially also in comparison, we see a quite interesting picture which deviates in many aspects between the industrial area, industrial robotics area, and the service robotics area. The first one is the size of the market. So in industrial robotics, we still have the typical supply chain of robot suppliers, system integrators, and end users. From the chart, you see that most of the value added is through system integrators. The IFR names a worldwide market of industrial robot applications of about 50 to 55 billion US dollars. So that's the world market. We have relatively few industrial robot manufacturers, about 55, maybe it's 60, but certainly below 100. So it's a relatively small size of industrial robot manufacturers. We have way more system integrators. And so I already talked about the annual growth rate and the average unit price. So the picture in service robotics is quite different. First of all, the market still is a little bit smaller. So in total, we have about 20, below 20 billion euro turnover at the moment. However, it's very strongly growing. Yet you see the annual growth rates of 14 and 23% for professional and domestic personal service robots. We have 720 suppliers of service robots. So it's a completely different, a way more fragmented market of quite many very small companies. However, there are also larger companies underway. We'll see that difference in a minute. And also striking is that we estimate that more than 70% of these companies use ROS in one form or the other. So use ROS in one form or the other. Maybe a couple of remarks on the service robotics market, because it seems to be fragmented and a little bit more complicated. How is statistics actually generated for that market? So the IFR reaches out to more than 700 service robot manufacturers, asks for numbers. How many robots were shipped last year? This means in 2017, how many, or what value was shipped, what is the forecast for the next 4 years, and both in units and in value. And then we also ask for other data, like what is the company size, age, status, and where's that company located. You can retrieve quite a big deal of these figures from databases, and we see that there are quite many different application areas, and in total there are about 60, starting with field robotics, and within that category, field robotics, there's also different types of robots, for instance, for milking robots, or for the barn, or for broadacre, for harvesting, and so forth, so that there are quite many types of robots, professional cleaning, and so forth. You have seen some of the examples, and on the next slide we have here we see on that slide the main application areas and the growth rates, and we see pronounced growth in logistics, in the medical domain, in field robotics, which means agriculture, and of course defense. And don't be mistaken for the blue bar. The blue bar actually comprises numbers in terms of sales for the next 3 years. Maybe one remark is that these are all conservative estimates, because only those numbers which are reported make it into the statistics. So, for instance, we have a very good feedback from companies, for instance, producing agricultural robots, and we have a way worse feedback, for instance, from companies in the defense area, for obvious reasons. So, since we only use data which are reported or which are existing, the actual numbers might be still higher. Okay, so for the household and private domestic domain, numbers are also quite interesting. So we have here two main categories. These are household robots. This is mostly vacuum cleaners, window washers, and lawn mowers. And the fourth category is entertainment and leisure robots. So robots which cost a couple of €100, and so that's the situation at the moment. When we sum it up, then we talk about a market of, as it was already mentioned, of slightly more than $11 billion with this growth numbers which were indicated. One remark is also, in the past we counted drones being robots, and we, in 2016 we have given up on counting drones because there are quite too many, and the industry was also very fragmented, very difficult to reach, and obviously there's now our own statistics on robot drones. Interesting is, when we talk about 720 companies worldwide offering service robots of any kind, where are these companies located? What is the age of these companies? And here we see, for instance, that still most of the service robot companies are located in Europe. And you see about 30% of these are startups. And we count startups as companies which have a product on the market and are less than 6 years old, so 5 years maximum. So that's a startup in our case. So followed by US, and you see, for instance, quite many European countries. Again, the Europe bar is the sum of the European single bars added, and so that's the situation as we see it at the moment. When we look at where, in what area, in what applications areas are how many companies, then for instance in agriculture we see quite many, in AGVs, in manufacturing. So this is all what we would have anticipated. Yes, and finally, how large are these companies in terms of workplaces? Also, that's a picture which would have estimated that quite obviously there's a large number of small companies now appearing on the market, which have only 1 to maybe 50 personal or employees, or maybe 200 employees. So the mid-range is fairly empty. And last, on the other scale, we have very large companies like Siemens, like LG, like other multinational corporations which have robotics research, which have robotics products already in their portfolio. So that's it for now as a short overview on technology, on statistics, on markets, and I'm of course very happy to answer your questions. Thank you.
We are at a ROS conference. Can you give some outlook on usage of ROS and industrial robots?
Uses of ROS in industrial robotics?
Yeah, is there somebody looking at it? How often is it used? Is it for production or for research only? And what's the estimate of it?
So we do not have figures. Maybe there are estimates among people deeply involved in the ROS Foundation, or ask maybe Mirko from the memberships. We do not have that for industrial robotics, but for service robotics. So we can, and the number is actually, as you have seen, I also asked some colleagues from the Open Source Robotics Foundation. They even estimate the number to be a little bit higher than 70%, but I think 70% is a realistic figure of the companies in service robotics using ROS. So that figure is relatively accurate, I would say, because we actually measure it, or we count it, or retrieve it from material, but for the industrial robotics case, we don't have these.
There was a second question.
My question is, you mentioned there are about 60 or so robotics companies, like industrial robotics. I guess there are a few more in China also. So are these counted here, or how are these represented in your statistics? So I guess it's very dynamic. There are companies being formed, folding again.
Yeah, of course the picture is a little bit opaque, especially also in the service robotics domain. It's much less opaque in the industrial robotics domain. In the industrial robotics domain, we have about, in this calculation or in this list, we had about 20 Chinese companies. Yeah. For the service robotics case, it's very, very difficult, because very often you do not know, is this a lab, is this already a company, is this a product, or is it only a CAD information which they have? So we are counting in the service robotics domain only companies which have a product on the market. So as I mentioned it before, so that filters down a little bit the number which you may take from poor web presences.
But I think you're always looking for new companies to be, I mean, if you're aware of companies and you think they're not in the statistics, just...
Of course, we don't do it by ourselves. We have at IFR people doing this or helping us in this area. Also, I work quite closely with Frank Toby, who always sends me his figures, and we double check these. So the information you should have in the report should be fairly accurate. Maybe with some, carefulness with China, because we don't have an official reporting in this area.
Okay.
Thank you. As you were talking about service robotics, I had a question that is the market will be held more by wheeled robotics than like robot manipulators in the future? And is it more in omni wheels, or do they still use like diff drive, like in that sense, from technical perspective?
So as you remarked, most of the applications are mobile. Yep. We do not distinguish, or we do not make a statistics on the wheel or the drive kinematics. However, in the industrial robotics field, there is a differentiation in types of kinematics and in load capacity, etc. There's differentiation in the mechanical part of the robot. We do not have this kind of differentiation in the statistics yet for service robotics. But once we look into the report, I would say the typical standard case is differential kinematics. Yeah.
Okay. Then last question. Okay, a quick one. Okay.
Okay, so within mobile robotics, how do you see the future of mobile manipulation, in which there is a base and also a robotic arm on top of it?
So you have seen so most of the robot applications, service robotic applications, mobile. An obvious extension is to have a mobile arm, to have an arm added on the mobile base. There are already quite a couple of designs. However, there's always a negative side to this, because once the robot actually moves, you probably do not actuate the arm. Then you may have additional safety precautions you have to observe. In total, I would say mobile manipulation is, from a technical point, achievable. And I know of quite many pilot installations in industry and also in the service robotics sector, but still it's an exception. Maybe it's a future trend, maybe also like some kind of humanoid two-armed configuration, but that's in the future.
Good. Then,
okay, then thank you.